From the vastness of space, our planet appears as a shimmering blue marble. Well, this vibrant color is not rock, nor is it land. It is water. Water covers more than 70% of the Earth's surface, a constant moving presence that defines our world. It fills the immense oceans, carving coastlines with its ceaseless motion. It flows in great rivers, acting as the arteries of our continents, carrying life-giving sustenance across thousands of miles. This single substance, a simple combination of hydrogen and oxygen, H2O, is the most powerful and essential resource we have. Without it, the story of life on Earth could never have begun. This liquid is the cradle of all living things. Life first emerged in the ancient oceans, and for billions of years it remained confined to that aquatic realm. Even today, every plant, every animal, every human being is intrinsically tied to water. It is the solvent of life itself, enabling the complex chemical reactions that power our cells. It is the blood in our veins, the sap in the trees, the moisture in the air we breathe. The journey of water across our planet is a story of connection, linking the highest mountains to the deepest seas and every creature in between. The global water cycle is an immense planetary engine, a system of perpetual motion driven by the energy of the sun. Water evaporates from the surface of the oceans, rising as vapor into the atmosphere. There it cools and condenses to form clouds, which are carried by winds across the globe. Eventually, this moisture returns as rain or snow, replenishing rivers, replenishing lakes, replenishing underground aquifers. This elegant, self-sustaining process distributes water and regulates our planet's climate, absorbing and releasing heat to maintain a delicate balance. Yet, for all its abundance, the water we can actually use is remarkably scarce. Over 97% of Earth's water is salt water, found in the oceans and seas, undrinkable for us and unusable for most crops. Of the small fraction that is fresh water, the majority is locked away, frozen in glaciers and polar ice caps. The water we rely on for survival, the water in our rivers, in our lakes, and accessible groundwater, makes up less than 1% of the total. It is a finite and precious resource, a treasure we must manage with greater wisdom and care. For as long as humans have walked the earth, our destiny has been shaped by water. Our earliest ancestors followed the rivers, knowing that where water flowed, life could flourish. It was along the fertile banks of great rivers like the Nile, the Tigris, the Indus, that the first great civilizations were born. These waterways provided drinking water, reliable food, and transportation. They allowed for the development of agriculture, which enabled permanent settlements, villages, and sprawling cities. The story of human progress is the story of our relationship with water. We learned to control it and to harness its power. We built canals to irrigate vast fields, turning arid land into breadbaskets. We constructed aqueducts to bring clean water to cities, improving sanitation and public health. We erected massive dams to generate electricity and to create reservoirs for drought. Engineering and managing water has been a cornerstone of our success. Today, our dependence on water is greater than ever. It underpins the global food supply, with agriculture using the largest share of fresh water. It is essential for health and hygiene in dense cities. It is critical for industry, manufacturing, cooling, and producing nearly every product. Water is the silent force powering our modern world, fueling economies and sustaining our way of life. This reliance places us in a precarious position. The world's population keeps growing, driving demand for a finite resource. Meanwhile, the climate is changing, altering rainfall and making supply less predictable. We face a defining question: how can we thrive as water comes under pressure? How will we protect this vital resource for future generations? Our modern world is sustained by an ever-growing thirst for water. In the last century alone, the human population has more than quadrupled, and every new person adds to the demand on our planet's finite freshwater supply. As nations develop and economies expand, our per capita water consumption also rises dramatically. We build more homes that require running water, eat diets that are more water-intensive, and produce more consumer goods. This combination of more people and more consumption per person is placing an unprecedented strain on the rivers, lakes, and aquifers that have sustained us for millennia. The single largest consumer of our freshwater is agriculture. It accounts for roughly 70% of all the water we withdraw globally. In many of the world's most important agricultural regions, like the Central Valley of California or the plains of northern India, we are using water much faster than nature can replenish it. This relentless demand is draining ancient aquifers and causing major rivers to shrink, sometimes to the point where they no longer reach the sea. The challenges we face are not just about the quantity of water we have, but also its quality. A major source of this pollution is untreated sewage. In many developing parts of the world, a lack of adequate sanitation infrastructure means that raw human waste flows directly into the rivers and lakes that people rely on for drinking, cooking, and washing. This creates a tragic and preventable public health crisis, spreading waterborne diseases like cholera and typhoid that afflict millions, particularly children, every year. Agriculture, our biggest water user, is also one of our biggest polluters. To boost crop yields, modern farming relies heavily on chemical fertilizers and pesticides. When it rains, or when fields are irrigated, the excess chemicals that are not absorbed by the plants are washed off the land into nearby streams and rivers. These nutrients, particularly nitrogen and phosphorus, can trigger massive algal blooms that starve the water of oxygen, creating vast dead zones where fish and other aquatic life cannot survive. Our climate is changing, and this is fundamentally altering the global water cycle. A warmer atmosphere can hold more moisture, which leads to more extreme weather events. The result is a dramatic increase in the frequency and severity of floods. Rivers overflow their banks, inundating cities and farmland, destroying homes, and contaminating water supplies. Paradoxically, this same atmospheric change is also making droughts more intense and prolonged. Higher temperatures increase the rate of evaporation, drying out the landscape even faster. These extremes of flood and drought represent two faces of the same crisis. They are a direct consequence of a supercharged water cycle, a system thrown out of balance by a warming planet. Faced with these immense challenges, it would be easy to feel overwhelmed. But across the globe, a quiet revolution is underway, built on a simple yet powerful principle: efficiency. The greatest and cheapest source of new water is the water we already have, but which we currently waste. In agriculture, farmers are adopting precision techniques, most notably drip irrigation. This method delivers water directly to the roots of the plants, drop by drop, reducing water use by up to 70%, while often increasing crop yields. In our cities, investing in modern infrastructure and using smart sensors to find and repair breaks in underground pipes can save enormous volumes of water. At home, simple changes, when adopted by millions, can have a huge collective impact. Installing water-efficient appliances, fixing dripping taps, being mindful of daily use. Industry is also finding water efficiency makes economic sense, redesigning operations to recycle and reuse water multiple times within facilities. In the world's most arid regions, human ingenuity is turning to a source that was once untouchable: the ocean. The process of desalination is removing salt from seawater to produce fresh water. Modern desalination plants, particularly those using a process called reverse osmosis, force seawater through fine membranes that trap the salt, allowing fresh, pure water to pass through. Innovation continues, with scientists developing more energy-efficient membranes and engineers finding ways to power desalination plants with renewable energy. Another vital source of water flows through the sewers beneath our cities. Advanced wastewater treatment is changing the paradigm from a linear model to a circular one, allowing water to be reused. A new approach seeks to work with nature, restoring the natural systems that capture, clean, and store water for free. One of the most effective strategies is the restoration of wetlands. Wetlands act as natural sponges, soaking up floodwaters, and as nature's kidneys, filtering pollutants and purifying water. Another strategy involves giving rivers more room to move, removing obsolete dams and reconnecting them to their historic floodplains to reduce flood risk downstream. In our cities, creating sponge cities with green roofs and permeable pavements allows rainwater to soak into the ground, preventing urban flooding and recharging groundwater. Some of the most powerful solutions are rooted in governance and the collective action of communities, creating transparent and equitable systems for managing their shared water. We are also seeing incredible success stories emerge from community-led initiatives, where local people have revived traditional rainwater harvesting techniques, empowering them to take control of their own water security. These stories show that when people understand the value of water and are empowered to act, they can become a powerful force for change. We have journeyed from the molecular dance of H2O to the vast planetary engine of the water cycle. We have seen how this simple liquid shaped our continents and cradled civilization. It is, without question, the most precious liquid on Earth. Today, this life-giving force is under unprecedented pressure. Our soaring population, our insatiable thirst for growth, and a changing climate have strained the systems that have sustained us for millennia. Yet, in the face of this immense challenge, there is reason for hope. We have seen how human ingenuity is developing new technologies, the wisdom in working with nature, and the power of community to protect and share their common resource. The path forward requires us to see water not as a limitless commodity to be exploited, but as the fragile and finite foundation of our collective well-being. The challenge is great, but our capacity for innovation and cooperation is greater still. The fate of this precious liquid, and indeed our own, rests on the choices we make now. It is a defining moment for our species.